Hey there, have you ever been out on a walk and picked up a cool-looking stone? I mean, they're everywhere, right? On beaches, in the mountains, even in the buildings we work in. But what are they, really? Today, we're going to crack open the world of geology to find out. Let's get into it.
So you hear the words rocks and minerals all the time. Maybe you even use them interchangeably. But turns out they are fundamentally different things. By the end of this, I promise you'll be able to spot the difference like a total pro. All right, take a look at these. On the screen, we've got a mineral and we've got a rock. One of them is a pure single substance, kind of like flour in your pantry. The other one? It's a mix of different ingredients, like a finished cake. Any guesses which is which? Well, let's find out. To really get to the heart of it, we're going to use a surprisingly simple and kind of brilliant analogy. So forget about geology for just a second and think about something you definitely played with as a kid, modeling clay. This right here breaks it down perfectly. Just imagine you've got separate balls of clay. One's green, one's blue, one's red. Each one is a pure substance, made of only that one color. In our little story, those are the minerals. Now, what happens if you grab a piece from each of them and squish them all together? You've just made a rock, a substance made from a mix of different minerals. It's really that simple. Okay, so let's make it official. A mineral is a pure, naturally occurring substance. It's made of just one thing. Think of it as a basic building block. Quartz, for example, is just quartz. Feldspar is just feldspar. They are the pure ingredients in Earth's kitchen. And a rock? Well, that's what you get when you mix those mineral ingredients together. It's a combination of two or more minerals, all mashed up by nature. It's the finished recipe, the final product. And here is a perfect real-world example. This is granite. You've probably seen this on kitchen countertops. If you look really close, it's not one solid color, is it? It's speckled. And those different colored flecks, those are actually different minerals. You're literally seeing little bits of quartz, feldspar, and mica, all locked in there together. So if minerals are the basic ingredients, how do scientists even tell them apart? I mean, there are thousands of them. Well, geologists basically act like detectives, and they have this special kit of clues they look for to identify their mineral suspects. The first clue is called luster, and really, that's just a fancy word for how shiny a mineral is. It's all about how light bounces off its surface. Some look like metal, others look glassy, some might even look waxy, and some are just plain dull. Here's a great comparison. On one side, you've got gold, which has that classic, unmistakable metallic luster. And on the other, there's quartz. See how it's also shiny, but in a totally different, glassy way? Like a piece of broken glass. Both shiny, but a totally different luster. Next up in the detective kit is something called streak. Now, this isn't the color of the mineral itself. It's the color of the powder it leaves behind when you scrape it against a rough surface, like this unglazed tile called a streak plate. And here's the really cool part. A mineral's streak can be a completely different color than the mineral looks on the outside. This is a fantastic clue for geologists because while a mineral's surface color can change, its streak color is almost always the same. It's like finding out the mineral's true colors. The final clue in our basic kit is transparency, and it's super simple. How well does light pass through it? If you can see clearly through it, like a window pane, it's transparent. If light gets through but things are blurry, like frosted glass, it's translucent. And if no light gets through at all, like a piece of coal, that's opaque. All right, now for one of the most famous tools in all of geology, the Mohs hardness scale. To figure out how hard a mineral is, we don't crush it. We see what it can scratch and what can scratch it. It's all about who scratches whom. This clever system was cooked up way back in 1812 by a German geologist, Friedrich Mohs. He created a super simple ranking system from 1 to 10. 1 is the softest mineral you can find, and 10 is the absolute hardest. And here's that scale in action. At the very bottom, number 1, you've got talc. It's so soft you can literally scratch it with your fingernail. Kind of in the middle, at a solid 7, there's our old friend quartz. And all the way at the top, the undisputed champion of hardness, a perfect 10, you guessed it, the diamond. So here's the one simple rule you need to know. A higher numbered mineral will always scratch a mineral with a lower number. So topaz, which is an 8, will leave a mark on quartz, a 7. But if you try it the other way, quartz can't make a dent in topaz. It's basically the ultimate king of the hill test for minerals. Okay, so we've got our mineral ingredients all identified. Now let's get back to the final product, the rocks themselves. We know they're a mix of minerals, but how does that mixing even happen? Well, it turns out there are three main families of rock, and each one has a pretty dramatic origin story. They are born from fire, from water and sediment, and from some seriously incredible pressure. First up, we've got igneous rock. That name actually comes from the Latin word for fire, which is perfect because these rocks are formed when magma, that's hot, molten rock from deep inside the earth, cools down and hardens. This is rock born from intense heat. Next is sedimentary rock. This family forms from sediment, tiny little bits of sand, mud, and pebbles that have broken off other rocks. These bits settle down, usually at the bottom of a lake or ocean, and they build up in layers. Then, over millions and millions of years, the weight from all the layers above squeezes them together until they harden into solid rock. And last but not least, we have metamorphic rock. That word, metamorphic, literally means to change form, and that is exactly what these rocks are. They start out as either igneous or sedimentary, but then they get buried deep inside the earth where intense heat and pressure kind of bake and squeeze them into something completely new. So let's just put it all together real quick. You've got igneous rocks born from cooling magma. That gives us stuff like granite. You have sedimentary rocks built from layers of compressed sediment, which gives us sandstone. And finally, metamorphic rocks, which are older rocks transformed by heat and pressure into something new, like marble. Three totally different origin stories, creating the three main rock families. So just remember this. Every single rock you see tells a story of fire, a story of water, or a story of immense pressure. The Earth is literally writing its autobiography in stone all around us. Now that you know the basic language, the difference between a mineral ingredient and a rock recipe, you can actually start to read it. So what story will you find first?